have to use the L1, which is your midpoint, because we're using this number to represent the whole class. And then your L2, which is your frequency, which is how often does this midpoint appear. We don't know the individual data, we just average your class, which is your midpoint. And once you type in L1 and L2, this is what you need to do is we need to go to the calculation. We need to go stat, calculate 1 for stat. And then when you have your window prompt on, your list, you have to type in L1. Your frequency list, you have to type in L2. And your calculation, you just select your calculate, press enter, and they should give you your answer. Okay. So again, whoever have 84, see if you guys can do that. Let me go back to 83 because this is where the 83 is different from the 84. And whoever don't know how to type in your L1, your L1 and L2 is right here, which is for your 84. You probably see L1 right here on top of number 1, and your L2 is on top of number 2, which is in order to type that, you have to hit second, number 2, and so on and so forth. So if you're using this thing here, we know the answer is 48. Let's take a look at this thing here, which is, let me edit. And again, my screen is gone. So if you want to clear your item, remember, you have to go to L1 and clear, right? So let me remove this thing here. If you don't remember, I think I blocked it. So let me remove this so you guys can see your data, your midpoint, right? So your midpoint is here, which is, again, if you look at this thing here, your midpoint is you have 8, you have 24, 40, 56, and 72, right? So we have 5 data, that's my 5 data. And now we go to the L2 and you type in your frequency. Reminder, your frequency is L2 and your midpoint is L1. And your frequency, you type in again, the 2, right? The 14, the 6, the 13, and the 15. So you have that, which is now, again, your 84 is the same. You press stat. Now we go to calculate and you select 1 for stat. Like I say, if you have 84, you will have this prompt. You have to, for your list, you have to type in L1. For your frequency list, you have to type in L2, and then you select calculate. If you have 83, you have to manually write the comment in. You have to type in L1, which is second, number 1. You type in L1, and then you have to hit comma, second, number 2 to tell them to calculate L1 and L2. So if you have 83, you have to manually type in your command. You have to tell your calculator, take my L1 and my L2 and calculate it, okay? If you have 84, you don't have this screen right here. You have the screen right here, which is your list, your frequency list, and your calculation. And then you press enter. This should be your screen, which is, again, everybody see that right here, this 48 is my mean. And if I go down, my median is 56. Okay, so again, 83, you probably, hopefully you guys see the same screen I have up here. 84, you probably see the same screen, but question, whoever have 84, question on how to type in your window prompt. So everybody good to go? All right. If no question, let's continue, right? So looking at this thing here, which is, again, if they ask you for the mean, your mean is 48, and again, your median, you just go down. Your median will be in this case 56. Okay. So now, if you don't have question, those are the only 3 items we have in 3.1. Okay. So 3.2, which is, this is the last chapter last section we covered today, which is 3.2. This is what we want to do is, again, 3.1, we want to measure the middle of your data. Now 3.2, we want to measure how spread out your data is, right? How how spread out your data is, which is the first thing we want to do. The first definition we have is the range of your data. And the range of your data is, reminder, the range of your data is basically take the largest data minus the smallest data. And again, basically we want to know how, from the smallest number to the largest number, how far apart are they? Okay, question? Somebody have question? All right. Again, basically we want to know how many different units from the smallest data all the way to the larger data, and that's your range. Okay, so now the second thing we have is the variance. And ladies and gentlemen, like I mentioned to you guys, this is where the notation come in very, very important. You have to know that the population variance is your sigma square, and the sample variance is your S square. Okay, so this is your variance, which is S square for your sample variance, and sigma, which is kind of like a canon square, that's your population variance. Okay, so what is the variance? The variance is basically the different, the square different, your data square different from the mean, right? What is the average difference square from the mean? Meaning whatever your data is, you square them up, and we want to see how far apart is each of your data square far away from your mean. Okay, so again, looking at this thing here, which is, again, to do this on your book, we have, again, this is your steps, the 5 steps to find the variance, population variance and the sample variance, which is, again, the first thing we need to find the mean, which is for population variance, we find the mean. And the second thing we need to do is find the deviation, which is take each of your data minus the mean, and then we square them up, we add those results, and then we divide by the total number of data. And again, the only thing different between the population variance versus the sample variance is, instead of divided by the total number of data, we have to take the n minus 1. Reminder, the sample is a portion of the population. So we have to use a smaller number to estimate the population. So we want to, again, because we use a smaller number, we kind of overestimate the population, and we want to overestimate something rather than underestimate them. Okay, so the sample is basically you divide by n minus 1. Later on, you will see that n minus 1 sometimes say the degree of freedom, but that will be in a later chapter. For now, this is the step that if you were to do it by hand, right? And again, let's take a look at the next thing we have is the standard deviation. So the variance is the different square of your data, right? The square of your data, how far of each of your square of your data away from the mean. The sample standard deviation and the population standard deviation is basically what is the average difference from your mean, right? What is the average difference? Meaning some data is above your mean, some data below your mean, but what is the average difference among all those data away from the mean? Okay, and again, what they tell you to do is to find the standard deviation. All you need to do is take a square root of your variance. Your variance is the S square, which is your sample variance is S square. We take a square root of your variance, you get your S, which is your standard deviation. Your population standard deviation, your population variance is sigma square. We take a square root of sigma square. We get sigma, which is your sigma is your population standard deviation. And again, this is what we have is if you square your data, for instance, let's say if your data is in feet, right? And you square the feet, you will get square feet, right? Meaning again, your variance, the unit, your variance is in square feet. But to get the square feet back to your feet, you have to basically take a square root of that to give you back your original unit. So again, your variance will have a square unit and your standard deviation will go back to your original unit. That's why we have to take a square root, okay? So let's take a look at this thing here. Let me ask you, the 3 things we have was, again, the range, the variance and the standard deviation. So let's say if they give you this data and they ask you find a range of your data, find the sample variance and find the standard deviation for the following sample. So we know that this is a sample, so we're using the S, not the sigma, right? We're using the S here. So let me ask you guys, what are my range? How do we find a range? Do you agree that to find a range, all we need to do is take 25 minus the 3, guys. Sorry for the typo. 25 minus the 3. The 3 is the smallest data here. To give you 22. So sorry for the typo. 25 minus 3 will give you 22. So the range is 22, meaning from the smallest data, which is the 3, to the highest data, which is the 25. Okay. Let me change that. So now, let me is the 3. And now let me ask you guys this thing here, which is, let's say if you have this item, let's use what we have before. So let's enter this data into your calculator. And again, let me do the shortcut. And you probably, you probably say, wait a minute, Mr. Tran, all the formula you give me, why we don't use it? Again, your calculator can help you in terms of that procedure. So let's take a look at this thing here. Let's say, let's enter this data into your L1. Okay, so again, let's say if I want L2 to be clear, reminder to clear your L2, you go L2, you click clear and then enter. Okay, so make sure your L2 is clear. And let's go to L1. And again, you don't have to clear. You can just type in overlap and they will cancel out for you. So let's say if I have this, which is I type in 16, I type in the 6, I type in the 18, I type in the 3, 25, and 22. So if you type it in, if you have 83, this is what you have. If you have an 84, you will have a little bit different when you click on this thing here. If you have an 84, make sure that your frequency list is blank. Reminder, your frequency list is blank. If you have 83, you just press enter. Again, the item we have is the item you have is 83. They is automatically calculate for you. Question? Question? No question? All right. So looking at this thing here, let's take a look at the output, ladies and gentlemen. So we mentioned this thing already, right? X bar is your mean, right? We mentioned that X bar. This thing here, which is the sum of X, which is basically if you take each of your X, you add them up, is equal to 90, which is again, if you take 90 and divide by 6, that's where you have a 15 come in, right? But we don't really need that. Sum of X squared is basically tell you that if you take each of your X and you square them up and add them, you have that. But we don't really care about those two for now or ever in terms of this. This is the two I want to focus in it. Everybody see the S and everybody see the sigma. So the S, reminder, what is the symbol for S? Reminder, the S is your sample standard deviation. That's your S. And your sigma, this one here, that is your population standard deviation. Everybody see the S and the S bar here. So the S is your sample standard deviation and the sigma is your population standard deviation. And that's the only thing they give you, ladies and gentlemen. That's the only thing that your calculator give you is the standard deviation. So the question is, if we know that if we have a variance and we take a square root of the variance, we will get the standard deviation. Now, let me ask you guys, if you look at the screen, if you look at this thing here, you probably see the answer. If they give us the standard deviation, how do we find the variance? Well, instead of a square root, everybody agree that we have to square them up, right? So everybody see that your calculator give you the standard deviation. That's the only thing the calculator give you, which is the output is the standard deviation. to find a variance, we have to take the standard deviation and we square them up, time itself. Okay, so in this case, because they ask us for the sample, we have to use the S. Everybody see that I'm not using the sigma, I'm not using the 8. Because the problem that are we dealing with is the sample, so we have to use the S. My S is 8.7635. So what will that be? That will be, again, remember, because they don't tell us how many decimal they want, which is, again, our answer will be 8.8. Here come, ladies and gentlemen. When you find your answer, please do not round your answer in the process, okay? You only round your answer at the end, okay? So looking at this thing here, everybody see that looking at this thing, all you need to do is you take whatever this standard deviation is, which is, again, 4 or 5 decimal places fine. You take this number and you square them, which is 8.7635. You square to give you 76.798. And then, again, all you need to do is take that and you kept 1 decimal place. Everybody see that if I were to take the 8.8, if I were to take the 8.8 and square that, meaning 8.8 times 8.8, everybody see that I have 77.44. And that's pretty much a lot bigger than this, right? So one thing is, because we round up the number here, because we make it bigger and then you square them, you make it another bigger. So it's too big, okay? So don't use in the rounding in your process of your problem. You only round at the final answer. That's when you round it. Okay, so again, don't use the round number in your process. Everybody understand what I'm talking about here, that we're not using the 8.8 rather than use the actual 8.76356 or something like that. We only round at the end, okay? So just to remind you is the output of the item here, which is, again, if we go to B, let me take a look at, if we go to B, as you can see here, B, this is what they ask you. And again, let me skip. Again, if you type this thing into your data, right? You hit stat, you type this thing into your data, and then you will see that this is the output they have. The output they have, and again, the two things we're looking for is S versus sigma. Why do I use sigma here? Someone might ask. The reason why I use sigma is because we are dealing with population standard deviation or population variance. And again, that is the very important key for you guys. And that is one of your objective or one of your goals from here on out is determine when are we using population versus when are we using the sigma. Okay, so everybody see right here, this is my when do we using the S for sample and when we using the sigma for population. And again, the reason why I use sigma right here, 17, is because that we deal with population. Okay, so again, you don't have to do all the steps that I mentioned earlier in the sense of the 5-step. Your calculator can do that 5-step for you. You just need to know which output we need to take out. And again, because of the output they give me 17, everybody see that the standard deviation is 17. All I need to do is take the standard deviation and square to give me my variance. Okay. And again, I think this one is right. 62 minus 4, that's right. 58 is the range. Question with the range, question with the variance, or question with the standard deviation here. Or question with your output. Okay, and one thing I want to strongly make sure you know how to use your calculator, ladies and gentlemen. 75% of this class probably will be calculator users. Because of the technology, we kind of bypass a lot of theory and concept behind it. And because of this structure, we will basically use a lot of calculator base to help you save some time to find your information. Okay, so again, if you have questions, let me know, later on in terms of the calculator base. Okay, so any question with your output here? Any questions so far? All right. If you don't have question, probably we can, we can stop here for today, in the sense that this will be what we will pick up on tomorrow. So again, the next thing we have is the empirical rule or a bell-shaped curve. Okay, so this is what we will do tomorrow, which is we will finish 3.2, and then we will begin 3.3, which is finish 3.3, which is that's the end of your first test material. Any question here in terms of any material that we covered today, or in terms of the calculator?